Hello and welcome to my YouTube channel, GeoHub. So today we will talk about the huge mountain, the high peaks on the surface of the earth, the Himalayan mountains, how they are formed, and what are the consequences that, and what are the forces they form. And we will cover this Himalayan mountain in the very north of Pakistan. What are the evidence that we have to say that these mountains are collided with each other. Uh, Next we have little about these pictures. The fold and Trust Mountains, Himalayan continent collision in the northern region of Pakistan. We have Tibetan Plateau, which is the evidence that a huge mountain or farm in the northern side. Starting from the Paleocene, Eocene, Oligocene, Miocene, and Pleistocene, these ages were covered through all these recent studies, and the Civilics were also covered and published many papers and in international journals. During the Jurassic period, the Indian flight had started their journey to move to the northern side during the breakdown of the larger mountain, where we have to see in the globes the shallow seas, the deep oceans, and then the landslide, and then the lowland and mountain region and the desert region. This was the scenario and the Jurassic period time, where the continents look like in that particular globe. So we have seen that the continents is moving, and particularly with the specific evidence that have to say that the continent move from one place to another, and yet they have a very huge motion, and when they are moved, there is a lot of consequences behind that movement. So the split of the Gondwana and actually the movement of the Indian plate toward the north is the story begin from the Jurassic time. Next, then we have some Cretaceous time, where the Indian plate moving from the north or southern side to the northern side and the Tethys Ocean. You can see the Indian plate is look like an ice lane in the huge Tethys Ocean, where the split of the Gondwana and the starting of the slow movement of the Indian plate toward the north is the journey begin from the Jurassic to Cretaceous. Then you've seen where we have to see very closely the Indian plate moves so close to the Eurasian plate, and then we have to the movement is a bit of slow movement, and from the southern side to the Eurasian, which is and the northern side. So this was the scenario and the Eocene time, a little more close to the northern side in that particular time zone. And then we have Miocene, where the Indian collide to the Eurasian plate, and then we have the consequences, and that consequences is in the present day. We see a huge mountain region. You can see here that the witness of those huge mountain region is the continent collision. So this was about the enigmatic little story of the Indian plate from the northern from the southern to the northern region. And then we have some cross section from the Himalayan origin. We said that the Paleo-continental thrust part is there. Then we have a Paleo-margin sediments and continental crust. Below that is the lithosphere, and then we have a asthenosphere, the thick asthenosphere, and then the oceanic crust, where we have seen and the previous animation that the Tethys Ocean is closed when the Indian approaching from the southern to the northern side. This was the Indian, and then exclusionary prism, exclusionary ridge is there. Then the port arc basin is developing. and the extreme southern, no, sorry, extreme northern side, we have a Tibetan plateau, and the very extreme north. This was the time when we have some Pleistocene time, subduction and transglacial system trade is developing at that particular time. Then we see the witness in the last previous imaging animation. Facial margin sediments partly subducted or so you under the movement is slowly and gradually starting. We will discuss later on in the lecture that what the movement is and how the movement is so much fast or so much slow that the movement is going on. But we have seen and witnessed this from a different angle, that now the Himalayan region in the present condition, they will collide with each other. The Himalayas is formed, and the paleomargin sediments is there. There are highly metamorphosed rocks, suture zones is there, Ganges plain. But this was the Tibetan plateau, which is maximum cover right now. The movement, while meanwhile the continents moving, Indian continent moving, and the Mycenaean, the scenario is look like the suture zone is here, paleo margin sediments is just closing this, the whole setup is just come very close to each other, and then the paleo margin sediments is get closer and closer, and there is a very huge mountain in the present time. You can witness this a huge terrain of sediments and crystalline zones combine in that particular collided zone of Tibetan plateau at the northern side and the Ganges plain and the other side, and then we have a huge mountain and collided zones, which is the results, which is the consequence of those Himalaya originating. So this is the aerial photo. This was the satellite image that just look the northern side, and then we so say the Tibetan plateau, and this was the huge mountain from east to west and from west to east, extending these Himalayan mountain region. And then we have particularly talk about its this zone where we have some of those particularly huge collided zone in the Pakistan. So another view from Nepal, Bhutan to the extreme Pakistan, and then from the northern side we have China, and then we have a very huge continent of Indian and then the Arabian Ocean. This was another one aerial picture from where we have to see lots of those region where we have some active spreading zones and the oceans from northern to east and south to north and east to west, and then we have some huge continents that are colliding. Later on we have another one. These are the huge mountains. Alpine Himalaya originating from east to west, from west to east, and then we have some other beautiful Indian origin. These the huge mountain yet cover the whole continent, the whole globe. These are the huge collided zones. These are the elevated zones on the present day and the globe. So this was the cross-section view, and this is the aerial geological fault, thrust faults, and the view, the crystalline zones and the sediments and the metamorphic rock zones from from Pakistan, India, Nepal, and then we have Bhutan. These are extreme east-west Himalaya originating. Continental arc zone, then we have Suture zone, Tibetan zone, Greater Himalaya, Siwalex. From this view, we have to cover this particular line in the northern, from northern to south and Pakistan. we have to cover the continental arc zone. Then we have Andes-Sucha zone, Tabiti zone, and Great Himalaya, Sivalics, and Lesser Himalaya. Some of the most important faults system they are relating, and then these are the thrust system, thrust faults and normal faults. And particularly, this was the cross-section view from the very south to the north, and when we go to the northern side, there is most crystalline rock, more hugely compressed and squished rocks, which is crystalline, and most of them are gneiss and metamorphic. This was the little story about the Himalaya, how they are formed, what are the consequences, and how this is a little bit introduction. The Himalaya provides a good look at continent-continent collision on the surface of the Earth. World youngest and highest mountain regions, world fastest uplift rate of 10 millimeter per year at the Nanga Parbat, which is published recently. World maximum relative relief is greater than 6,000 meter, and this valley is one of them. And world largest high plateau, Tibetan plateau, greater than 500 meter. Nice picture produced from almost orthogonal collision. This was the nice picture. So we will cover all those things that is come under the category of nice picture. Okay, tectonic development and brief. What are the tectonics and what? And a little bit we discuss in the animation at the early stages and the previous slides. Late Jurassic, what was the condition is that time? Northern Tibet collide with the Eurasian and Paleotethys Ocean closed. Kunlun range initiated. This was the scenario, which is the very initial stage of that collision. And then we have the Jurassic to early tertiary time. We have several oceans, or arms of oceans, open and closed terrains will move across the Tethys to the north. This was the scenario going on at the Jurassic time. And later on, we have the Eocene time, where we have a new Tethys Ocean closing, a new Tethys Ocean, and then the Indian continent collided with the Eurasian. This was particular the time where the mountain building process is starting. And Eocene to Holocene, Indians still pushing north into the Asia, which is the scenarios is going on to the present time yet. Okay, so this was a little bit a discussion about the introduction, that what was the condition and style. Then we have some pictures here from the northern Pakistan. We have to see who cover the Himalaya terrain and sector into in detail. Okay, the transect is covering here is Trans Himalaya, Higher Himalaya, Lower Himalaya, and then what the component, what the rocks yet they were identified, published in many of the journal. Okay, Karakoram batholiths is and very extreme. From Kunlun to the Kaistan Island Arc and the Suture zone, we have a Karakoram batholiths. Then we have a Trans Himalaya, the reddish color you can see here. This is the Trans Himalayan batholiths. Then we have some Tethys sedimentary rocks, and then Miocene granites and central crystalline zone, where we have to see those rocks are the central crystalline rocks. They were actually developed during that collision. Then we have Lower Himalaya and outer crystalline Nephites and Sivalik and Sub-Himalaya. Tibetan Plateau is the very north, and then we have Kunlun ranges and Karakoram southern Suture zone, Kaistan Island Arc, and then we have some Sivalics in the later stages. So this was the air view. Karakoram ranges between the Kunlun and the northern, what we discuss here. Remains of the Indian margin or thrust to south over Thailand. Okay, Ladakh is in between the main central of the main crystalline zone to the Karakoram ranges. Okay, then we have the very important feature, and that particular transit is the northern suture zone. Both melanges, mafic and ultramafic rocks and slates are there, which is their composition. Later on, we have a Trans-Himalaya. So now we have covered Trans-Himalaya a bit from the north to south, a plutonic belt comprising Andean batholiths. They were the extrusive rocks. And this suture zone, a narrow discontinuous belt of opulites, blue schist. Why there are a huge collision between these. So the opulites is also a part of that to evaluate or what we say the blue schist species or the metamorphic. Due to high compression, those crystalline rocks, the huge sedimentary and crystalline strata were very squeezed together. They were crunched together, so that's why huge forces and the outcome is in the form of metamorphic rocks. At the end of Rorik Arc Basin and the Central Himalaya, what are those? These are the particularly key features related to those Trans-Himalaya. Now, I'm going to say the cross section to get better understanding of what's going on, what the strata are, what the features are, and what the thrust sheets actually. When you collide both the continent with each other, there must be a thrust sheets. They are developing a phenomena of faulting. This faulting is evident in that particular regions, Pakistan, India. MFT is the youngest ball, and then we have from south to north MBT, MCT, main central thrust, main boundary thrust, and the very north we have main Karakoram thrust. Karakoram ranges former Indian margin range, Indian margins. Trans-Himalaya, Plutonic belt, New Tethys, Andean batholiths, and these are the and then we have some endless tangible feature zone where we have a narrow discontinuous belt of opulites, which is the black one. You can see here the blacks, these are the opulites, and blue schist, these are the red one. And then we have some four arc rocks and central Himalaya, which is this the blue one here. So this was from the central crystalline zone, Miocene granite, opulite nepes, Cretaceous batholiths. These are the zones which is in the vicinity of Himalayan region. Okay, then we have higher Himalaya, which is another good picture of what the rocks that have actually and how they are look like and what they are really covered, what the active faults is there. So we have a Tethyan sedimentary rocks here, and you can see the blue one is the Tethys sedimentary rocks, because it was the part of those Tethys ocean. It is the part of the shallow marine Tethys ocean. Then Miocene granites, and then central crystalline zones, and these was you enter the category of higher Himalaya. Central crystalline belt gold zones of amphibold species, gneisses, because it's a huge process involving there. So the rocks which is existing squished to each other and the outcome is the metamorphic rocks. And then we have Indian and Eurasian basement and then cover rocks. Cover is actually these recent deposits, which was the product of chemical and physical weathering. Electronous ophiolitic rocks derived from the Indus Zangpo Secret Zone Preserve and is a gneiss, amateur amphibolites rocks is present there. And then we have a granite plutons, very high sidereal ratio of 87 and 86, derived from a melting of a crust, which is the evidence of those. So this was all about the story relating to the higher Himalaya with the main features and the Himalaya origin. And then we have a lower Himalaya where we have to below the main central thrust, above the main boundary thrust, Proterozoic to low Paleozoic Indian geoclinal rocks through those particular zones contain a thrust south and Indian plates. You can see here this was the lower Himalaya is the out crystalline gneiss. You can see a little light greenish color outer crystalline gneiss. And then we have symbolics covers. Later on, we have to see this is the recent symbolics. They are at the very southern parts of those Himalayan sequence. So, thrust south and the Indian plates. This was the MFT, main frontal thrust. Sub-Himalaya cover a 7 kilometer thick unmetamorphosed molasse. Sediments of symbolic molasses, Oligocene to Holocene deformations, upset of the drivers, traces, and carried on a main frontal thrust. So this was the huge thrust. They were containing lots of thrust pods. So in the very south we have the salt range thrust or MFT thrust, which is a younger one. So lower Himalaya contain these. Then we have sub-Himalaya, which is mostly contain the symbolic molasses sediments. Okay, so this is the cross section. Now look at the cross section. What we say, what the zones we have covered yet to this stage is from the northern. We have seen higher Himalaya. Then we have the Trans-Himalaya, higher Himalaya, or then we have a lower Himalaya. So at this sequence of cross section, you can see there, these are the central crystalline bed. Which one is that? The greenish color. You can see here the greenish color here. If the very situation of main central thrust. And in this zone, you can see the greenish color. These are the crystalline bed. What they contain: core zone, Indian basement, and plus cover. These are the sediment. These are the rocks, particularly who exist with that particular zone. And then we have a Tethys Himalayas. What they are and what they contain. Actually, this zone is the Tethys Himalaya. Thrust staked. This was a thrust staked. You can see this is the zone which is thrusted, and this thrust is called MKT. And northern Indian margin. This was the extreme northern Indian margin. From where the sediments is coming, this is the zone of extreme north, which is sometimes the shallow marine zone of Tethys Ocean. Now there are actually coming in as evidence that somewhere they are actually is the shallow marine of the Tethys Ocean. But now you can see the evidence there. Electronous ophiolites. Somewhere you can see the black color. These are the electronous ophiolitic zones. And then we have a granite pluton. You can see here the evidence these are existing and the Tethys Himalaya, and then we have some central crystalline belt. We have granitic epauleite, a secondary Miocene crystal melting is actually, this is the secondary melting, and there are thrusted here. So it thrusted, we can't say that thrusted, but actually it is coming into this zone, because if you have a very huge compressional regime and the rocks is starting to melt, when this melting rocks is exist in the subsurface, they actually need a very weak zone where they can plume out. So that's why that a huge amount of silicon dioxide and the granitic composition contain basic composition, which is comparatively very less denser, and they try to push itself to move to the surface due to this very little density as compared to the surrounding rock, which is melting due to assimilation processes later on. Lower Himalaya, lower fall of that Andean plate, and lower fall contains sub-Himalayas. So unmetamorphosed rock movements in the Sibalic conditions. There you can see here these are the Sibalics. These are a huge amount of the sediments, which is recent, which is the lower part of the Andean Himalayas region, which is the Indian plate. Actually, this was the sketch actually drawn to see that is how the whole story, that what we are studying up to now, that what are those consequences creating this huge amount of mountain region. We will cover a lot on that. That was the Indian plate colliding with the Eurasian plate due to a processes, and in between the huge amount of the water is consuming the closing of the Tethys Mountain, and the closing of the new Tethys Mountain is a story of the Indian continent. And then we have some melanges zone, and the max lithology exists, evolutionary ridges, where we have to see some of the huge sedimentary strata, port arc basin, the photo subduction zone. Later on, these are the things that is existing in between from 120 to 60 million years. But the process is still going on, and after that 4 million years, the Indian collide with the Russian plate, and you can see the evidence in the greenish color is the accretional layers. Then is the we have the port basin, and then we have some sediments there. Then this is some magmatism is here going on in the northern side, which is the consequence of those colliding two plates. So the next stage, and the very last and the very recent stage, about 20 to 100, 20 to 10 million years, we can see the erosion is going on, because a huge amount of uplift that can then the superficial process is going on that, particularly the physical and chemical weathering, and that weathering don't erode all those sediments from there. And then we have MCT, MBT, and MFT at these stages. But you can see there, this was the scenario going on, and 20 to 10 million here. Then what the process is actually, what the published data tell us the story, and what they cover yet, according to the Earthquake Engineering Research Institute, EERI, the Indian tectonic plate migrate toward the north, which is discussed several times at a rate of 55 to 60 millimeters per year. This was the actual speed of the plate from south to north. Likewise, the Asian plate is moving in the same direction at 25 to 30 millimeters per year. This was the Asian plate moving towards the Indian plate at that particular speed. So you can see here, and in the context of continental movement, or tectonic plates movement, this was the huge amount of movement. The difference in the speed is responsible for the formation of these huge mountains. So you can see witness there, if the speed is how much faster the plate is moving, so that was the consequence to create the huge Himalayan mountain region. This area of motion, speed and direction create one of the most seismically active regions in the world and has been responsible for a number and major and minor earthquake in the region throughout the year and from the collision of that. We can see witness there now. We can see here from this we can see of the zones what we discover what we cover yet, but these zones will have some consequences in the area and the community in that particular regions they are existing. So you can see the Nanga Forbet, this is the MMT, and then MKT. These are the active zones actually from north to south to north. You can see here the black lines, the black thrust parts. These are the active particular zone from the north to south. There were yet we have a very different and difficult situation facing throughout the years. We have a minor and major earthquake throughout the years in this particular region. The reason behind that, the region of main tertiary collision between the Eurasian and Indian continental plates. You can see witness there. We can cover this every zone we have covered, and in particular the vicinity of Pakistan. Then we have main mantle thrust, main Karakoram thrust, main boundary thrust, Chaman trans current fault and or national fault and opuloids. These was the active zones from the very south Arabian Sea to the north of Pakistan and the Indian plate, which are the active zones in the surface of those clouds. There are silent tectonic features of Pakistan, which is the consequence of those continent collision. Another good features, another good maps, aerial maps, which is showing the active zones which are responsible for the earthquake in Pakistan. So thank you very much. If any question or there any discussion, any comment, you can put the comments and let me know what you are understanding from this lecture.